This is picking up on the purification of enzyme from a natural source, and where we left it last semester would have been redissolving a 70% pellet. So we had precipitated, salted out the tyrosinase. Okay, so we had a pellet, and then we redissolved it in 50 millimolar phosphate buffer, pH 7. Okay. This next step, there's still going to be quite a bit of salt that was in that pellet, and we want to do ion exchange chromatography. Okay. So in order to do the ion exchange chromatography, we want to make sure we get rid of all that excess salt so that the ion exchange chromatography can bind tightly to the protein. So we're going to need to dialyze the protein overnight. So dialysis tubing comes in a roll here. It looks like tape, okay, but it actually is a tube. So before you use this, you need to swell it for about a half hour in deionized water. So here I've got some that's been swelling for a while, and if you go back and forth between your fingers, you can get the tube to open up. This is a little bit futzy, but again, you can usually just roll it between your fingers and you get an opening there that you can put a funnel into. Okay. Sometimes when I've used this, I've just tied a knot in one end and opened up the other end and poured the solution I want to dialyze into it. We also have clamps, dialysis clamps, and these are nice and handy because they're easy to put on and off, and you can clamp the dialysis tubing with them, and just a little bit easier to handle than having to cut the knot off and tie the knots. So here's another piece of the tubing that I'd pre-swelled, has a clamp in the bottom, and I don't have a funnel handy, so normally I would use a funnel to fill one of these. This is just filling it with some deionized water. And see the tube fills, and you can always squeeze it a little bit, get the air out, and then use another clamp up on top. You might lose a little bit of solution when you clamp this. Okay, so now you can see we've got the fluid that we want dialyzed in the tubing, and then we take the buffer that we want it to eventually have. Okay, so again, if this were buffer, we'd place the tubing into the buffer, and I have it on a stir plate. You want to stir it. It can be a very slow speed, but what will happen is the buffer in the large beaker will exchange the buffer within the dialysis tube. So we'll leave this, takes quite a while, so we'll leave it overnight and actually do this in the refrigerator, and then when we come back, we'll have the dialyzed protein. This is the ion exchange step of the purification of the enzyme from a natural source. So we're purifying tyrosinase from mushrooms, and had a somewhat of dark color solution that I loaded on this chromatography column, and at the top of the packing you should see just a very narrow dark band, and that's where the tyrosinase is bound, and I have just a little bit of fluid above that, probably about half a centimeter, and I've been very carefully adding solution to wash through. I'm using 50 millimolar tris buffer, pH 6.8, and again just dripping that along the sides of the top of the column so I don't disturb the bed. Okay. Now I'm going to start eluting it with different salt concentrations, sodium chloride, 50 millimolar, 100 millimolar, 150 millimolar, and 200 millimolar. Okay, and I'll be adding that elution amount, 2 milliliters of each at a time, and again letting it drain out. Okay, and then I'll continue to let it drain, running through the 200 millimolar until I've used up all the solution. Down here, you can see it's attached. The column is attached to a fraction collector. The fraction collector is set up so that it's going to count drops. And every 20 drops, which is equal to a milliliter, it's going to shift. So again, I'll start to elute it with 2 milliliters of 50 millimolar sodium chloride. Okay, so we'll get 2 collection or fractions collected with that. And again, it takes a little while for it to come through the column. So we'll continue to collect, and then I'll load on top of that 100 millimolar. So the ionic strength keeps getting stronger. And according to the reference, at about 150 millimolar is when the tyrosinase should come off the packing. After this, I'll be analyzing all these samples for tyrosinase activity, and then also those that have tyrosinase activity, I'll do a biorad assay, and we'll be able to determine which ones, what the specific activity of this purified protein is coming off the ion exchange column. This is the chromatography column after we're done. Eluted the tyrosinase, and you can see a lot of debris still bound to the top of the column. Sometimes you can treat these with strong bases or acids and regenerate them, but this is probably about $4 or $5 worth of the packing, so I think I'll just throw this away and use fresh next time.